Hi students, welcome to Sunil's tutorial. I am Sunil Virwani and today we will be doing this chapter called as electrons and photons. Let's see this. Let's see the experimental setup. Draw the diagram for this. Done, everyone's finished drawing the diagram. Okay, let's try to do this. This is Millikan's oil drop method to determine the charge on electron. To determine charge Let's see this. Now, let's look at the apparatus, guys. Can you see the apparatus, please? The apparatus can. Right. Done. Let's see this. The apparatus consists of two plain parallel plates A and B, which are about 25 centimeters in diameter. The two plates are about 1.5 centimeters apart. You have these two parallel plates. They are about 1.5 centimeters apart, and they are maintained at a very high potential of 1000 volts. Right. The upper plate has small hole in it. A pin drop hole through which oil can be sprayed through the atomizer. This is the atomizer through which oil is being sprayed. Now, why do we use oil? Because oil easily acquires electric charge due to friction. Right? The whole arrangement is enclosed between a double-walled oil bath. Right? So as to maintain a constant temperature there. Right? You have two windows. A strong source of light is kept at one window. You have a lens. You have the focus at the other window, right? Yeah, that's your apparatus, right? So you have two parallel plates A and B kept at very high voltage. The upper parallel plate has pinhole in it through which oil can be sprayed. Oil is sprayed through the atomizer S. The whole arrangement is kept in an oil bath to maintain constant temperature. You have two windows. Through one of the window, a strong source of light is passed. At the other window, you have a focus telescope to look at the oil drop. Fine. Now, once oil is sprayed through the atomizer. Initially, there was no electric charge, but once oil is sprayed and you have the two parallel plates at 1000 volt, the oil will acquire some electric charge, owing to which it will remain freely suspended in that space between A and B. Right? Now let us assume that let M, rho and R be the mass, density, and radius of the drop. Right? Now, in that case, what are the forces acting on the oil drop? One, the weight of the oil drop that is going to act in downward direction. Right? I can say that the drop on the forces on the oil drop first, its own weight, which is going to be equal to mg, right, which is in downward direction. You can write this with me, guys. The weight of the oil drop mg, which is in downward direction. But we know that density is equal to mass upon volume. Thus, I could say that mass is equal to density into volume. The oil drop is in the form of a sphere. Volume of the sphere is 4 upon 3 pi r cube. Therefore, the mass of the oil drop is rho 4 upon 3 pi r cube. Right? So, I could say that mg is going to be equal to, instead of m, I can write rho 4 upon 3 pi r cube g. So this is going to be the weight of the oil drop that is going to be acting in downward direction, right? So this is the first force that will be acting on the oil drop. Now let's see which are the other forces acting. Now there is also going to be a buoyant force that is going to act in upward direction. To every force there has to be an opposite force. There is going to be a buoyancy force that is going to act in upward direction. So there is a buoyancy force acting in upward direction. Now which is this force? Now, force that is going to be acting in upward direction, let us assume that sigma is the density of the air. Then the force will be sigma is the density of air between plates A and B, then in that case the buoyancy force will be nothing but mg, but here the only thing is that the density will be not rho but it will be sigma. So in that case this force, buoyancy force, will be equal to sigma 4 by 3 pi r cube g, right? Now one is the downward force which is because of the weight, and you have a reaction force which is going to be in upward direction. Now the charge, there is also some charge on this oil drop, right? Due to the electric field. Let E be the electric field. Now since the oil drop has acquired some charge, there is going to be some force of repulsion of the oil drop with one of the plates of the electric field, and this force of repulsion and force of attraction between the two plates of the electric field is going to cause the oil drop to remain in the center, right? Now in that case, let's assume that Q is the charge that is acquired by the oil drop. Q is charge acquired by the drop. If Q is the charge acquired by the drop, then I can say that the upward force, that is that negative plate, is going to repel that oil drop in upward direction. So the negative upward force QE is due to electric field, now the fact that the oil drop remains freely suspended in that space, that means the downward force has to be equal to the upward force. The downward force is going to be because of the weight, the upward force is going to be because of the electric field. Since the drop remains freely suspended, therefore I can say that the upward force should be equal to the downward force. The downward force is rho 4 upon 3 pi r cube g, right? In which case I can therefore say that Q is equal to 4 upon 3 pi r cube g upon E, right? Now if I consider the buoyancy force also, in that case, if I consider the buoyancy force, then the net force that will be acting on the oil drop, the buoyancy forces, everything is same except that the density is going to be different, and the density is going to be because of the air that is there between. So the upward thrust that will be given to it, in that case the charge is going to be 4 upon 3 pi r cube. The upward thrust will be because of the difference between the density of the oil drop and the air that is there between the two spaces. So that is going to, I have
Q is equal to?
You have rho. Okay. Now the upward force is going to be because of the difference in density. So this is rho minus sigma. That's the difference between the density of the oil drop and the air between them, and G upon E. So that is going to be the charge on the oil drop. Now, Millikan made thousands of observations with different liquids such as oil, glycerine, mercury, and he found out that the droplet was always an integral multiple of 1.6 into 10 raised to minus 19 coulomb. The charge that would be existent on the oil drop, when you saw this, he found out that the charge that is existent on the oil drop is always an integral multiple of 1.6 into 10 raised to minus 19 coulomb. Thus, he concluded that since the charge on the oil drop is due to electron, hence he said that the charge on the electron had to be an integral multiple of 1.6 into 10 raised to minus 19 electron. After conducting experimentally found that Q is always an integral multiple of 1.6 into 10 raised to minus 19 electron. Sorry. Thus, he concluded that experimentally he found out that Q is always an integral multiple of this, irrespective of the material used. That is, whether he is using oil, glycerine or any other material used as oil drop. Okay. Now, thus he concluded that the charge on the electron had to be 1.6 into 10 raised to minus 19 integral multiple. Right? He said that the charge is existent on that oil drop because there must be some electron on it. Right? Hence he concluded that the charge on electron is 1.6 into 10 raised to minus 19 coulombs. Since in all the cases he found out that the charge was integral multiple of 1.6 into 10 raised to minus 19, he said that 1.6 into 10 raised to minus 19, since it is common with all of them, that has to be the basic charge on the electron. Now, we had already found out from Thomson's experiment also we have already found out from Thomson's experiment that E upon m, the ratio of E upon m is nothing but 1.7589 into 10 raised to 11 coulombs per kg. Thomson's experiment gives you this, right? Now, out of that I have just found out the value of E, hence I can find out the mass of electron. Substituting the value of E, the mass of electron can be found out. Mass of electron was found out as 9.107 into 10 raised to minus 31 kg. Thus, Millikan's oil drop experiment enabled us to find out the mass of electron. This is how the mass of electron was found out. Fine. Next. Now this was first. Now, there are certain substances such that the difference between their conduction band and forbidden region, the forbidden energy gap, is extremely small. As a result of which, even when small source of light falls on them, electrons are able to jump from the valency band to the conduction band, right? Such materials are called as photoelectric material, right? And this phenomena is called as photoelectric effect. What is photoelectric effect? It is the phenomena of emission of electrons from the surface of material, from the surface of metal, when a light of suitable frequency falls on it. When light of suitable frequency falls on certain metals, you have electrons emitted by them, and such phenomena is called as photoelectric effect. Can you just write this much down? Just write this down, leave space for this if you haven't copied this. Define photoelectric effect. Define photoelectric effect. It is the phenomena of emission. It is the phenomena of emission of electrons. It is the phenomena of emission of electrons from the surfaces of metal, from the surfaces of metal when light of suitable frequency is incident on them. When light of suitable frequency is incident on them. Now let's try to understand the photoelectric effect. Let's see how do we make a photoelectric cell. This is your experimental setup. You have this kept at a particular positive voltage. Let's try to understand what happens in the case of photoelectric effect. You have a window here and you have electrode, right? You have a window. Now let's first see the making of this. The apparatus consists of a glass tube with a side tube with quartz window. This is your window there. You have an emitter and you have a collector. Here's your emitter, here's your collector. Now let's try to understand how this whole thing works. As soon as light enters, guys, listen to this. As soon as light enters, it falls onto the emitter. Now the emitter acquires the electrons on that particular material acquires sufficient amount of energy and are emitted from the emitter and remain in this empty space between the emitter and the collector, right? Since the collector is kept at a positive potential, these electrons are then attracted by the collector and the circuit is completed. So that's how your solar cells work. This is your basic principle of working of solar cell. You have a photoelectric material. When light falls on it, it emits electrons. These electrons remain freely suspended in this space. Okay. Now, if the collector is kept at a positive potential, these electrons will be absorbed by the collector and your circuit will be completed. Fine, do we get this thing here? Now, in order to have those electrons emitted, the light that is going to fall on the emitter has to have a particular frequency. If I go on reducing the frequency, the number of electrons that will be emitted from the emitter will go on reducing. At a certain point of time, the number of electrons emitted from the emitter becomes zero. That means you need to have a minimum frequency for the light that is incident on the emitter. This minimum frequency is called as threshold frequency. So only if the light is above the threshold frequency, electrons will be emitted from the emitter. Fine, do we get this thing clear? As I go on increasing the frequency beyond the threshold frequency, more and more electrons are going to be emitted from the emitter. Fine. Now, even if no charge is there, now once light falls on this, you would have electrons emitted from here. These electrons are going to have some amount of energy. Now out of this, there are going to be some electrons which will have sufficient energy to reach the collector. Without any positive potential being applied to the collector, there will be some electrons that would reach the collector, as a result of which some current would flow in the circuit. Now suppose if I want zero current in the circuit, then I will have to keep the collector at a negative potential. I would have to give it a minimum negative potential so that no current flows through the circuit. This particular negative potential that has to be given to the collector so that no current flows through the circuit is called as stoppage potential. Right? So you have threshold frequency. Threshold frequency is the minimum frequency that the light should have, so that the light which is incident on the emitter should have, so that electrons are emitted by it. Second, as the frequency increases beyond threshold frequency, more and more electrons are emitted. Third, the magnitude of the retarding potential for photoelectric current to become zero is called as its stoppage potential. That is the minimum negative potential that should be given to the collector so that no current flows through the circuit. Fine. Can you just write these three definitions down? You want me to give the apparatus? Right, apparatus for experimental study of photoelectric effect. This is the diagram for apparatus for experimental study of photoelectric effect. The arrangement consists of an apparatus. The arrangement consists of a glass tube G. The arrangement consists of a glass tube G with a side tube The arrangement consists of a glass tube with a side tube with a quartz window W. With a quartz QUARTZ, quartz, that's a material, quartz window W. Emitter and collector are two metal plates. Emitter and collector are two metal plates fixed inside the tube. And serve as the two electrodes. Ultraviolet light enters from the source. Serve as the emitter and the collector, as the two electrodes. Ultraviolet light from the source enters the tube. Ultraviolet light from the source enters the tube through the quartz window and falls on the emitter. Falls on the emitter. The photoelectrons which are emitted by the emitter, the photoelectrons that are emitted by the emitter are collected by the collector and current begins to flow in the circuit. Right, that's it. Next, right, what is current begins to flow in the circuit? Next, define threshold frequency. The frequency at which photoelectric current begins to flow, the frequency at which photoelectric current begins to flow, photoelectric current begins to flow is called as threshold frequency. If the frequency of the incident radiation, if the frequency of the incident radiation, if the frequency of the incident radiation is greater than the threshold frequency, if the frequency of the incident radiation is greater than the threshold frequency, then the rate of emission is directly proportional to the intensity of the incident radiation. Next, what is stoppage potential?
Directly proportional to the intensity
Of the incident radiation. Next, what is stoppage potential? The magnitude of the retarding potential, the magnitude of the retarding potential for which the photoelectric current reduces to zero is called as stoppage potential. Right. The stoppage potential stops the electrons. Stoppage potential stops the electrons possessing maximum kinetic energy from reaching the collector. Kinetic energy from reaching the collector. Therefore, guys, I can say that the maximum kinetic energy of the electrons has to be equal to the stoppage potential into the charge on the electron. Therefore, I can say that kinetic energy, maximum kinetic energy that is possessed by the electron is equal to stoppage potential into the charge on the electron. I can also say that the stoppage, right please, the stoppage potential increases with the increase in the threshold, with the increase in the frequency of the incident light, not threshold. The stoppage potential increases with the increase in the frequency of the incident light. With the increase in the frequency of the incident light. Now guys, we said that light has to have a minimum frequency before photoelectrons can be emitted from it, and that minimum frequency we called as threshold frequency. If light has certain frequency, every frequency also has a wavelength associated with it. So if there is a threshold frequency, for that threshold frequency, the wavelength that is going to be associated with it is going to be called as threshold wavelength. Right? What is threshold wavelength? the wavelength which corresponds to threshold frequency is called as threshold wavelength. The wavelength that corresponds to threshold frequency is called as threshold wavelength. Right? I can say that threshold wavelength is C upon threshold frequency. Now, do we get this? We'll stop this here for the day. We'll continue with this in the next lecture.